Remember that the parent function of a parabola is y equals x squared. Notice there's no number in front of the x squared and there's no number after the x squared. So the parent function is just plain old ordinary 1x squared. Yesterday we talked about what happened when we put a number in front of the x squared. If that number was negative, it flipped the graph upside down. If that number was bigger than 1, it made it narrower. If that number was less than 1, it made it wider. Today we're going to look at what happens when we put a number added or subtracted after x squared. So grab your graphing calculators and punch in x squared plus 3 into the y equals button. So in your y equals button, enter x squared plus 3. And then to look at this graph, we're going to push the graph button. What do you notice about this graph? It's up high. That's one way to describe it. So this graph, the vertex is not at 0, 0. How many does it look like this graph has moved? The graph has moved up. It moved up 3. Okay, now look back at the equation. If the graph moved up 3, what do you notice about the equation that might be linked to the fact that the graph moved up 3? It says plus 3. So this graph moved up 3 when we added 3 after the x squared. Now we do need to get this graph on our paper. So now that we've seen, ooh, that's cool, that's cool. How do we put the points on the graph and actually put it on our graph paper? Push second graph, that goes into your table, and you can record some values. Find that symmetry point, find where x is 0. So let's see, where x is 0, I think I'm going to use -2, 7, because -3, 12, that's not going to fit on my graph. So I'm going to use -2, 7, 0, 3, oops, I forgot one. -1, 4. And plot those points so we can graph it. And when you're connecting your points, remember that you can go back to that picture of the graph and make sure that you are connecting your points so it looks like the graph on your screen. When we compare it to the parent function, we would say that it shifted up 3 units. And I really want you to notice up 3 units, and in the equation, it said x squared plus 3. So I want you to make the connection between that plus 3 in the equation and the fact that the graph shifted up 3 units. Because in example 2, before you plug it into your graph, we are going to make a guess. What do you think is going to happen? Okay. So it says -5. What do you suppose that -5 is going to do? It's going to shift this graph down 5 units. Now, plug this into your graph and look at it, get the points, put it on your graph. And look at that, we were right. It shifted down 5 units. Second graph, record some points. And as you're connecting your points, remember that you can click back to that graph. Make sure that what you are graphing on your paper looks like what is on your screen. At the bottom of the page, it says analyze. What is the role of c in the equation y equals ax squared plus c? Plus c tells us how much the graph is going to shift up or down c units. So if it's plus c, it's going to shift up however many units c is. If it's minus c, it's going to shift down however many units it says. Okay, on the front side of the notes, the only thing in that equation was the plus 3 or the minus 5. So turn the page, and before we plug it into the calculator, we're going to try to combine what we learned yesterday with what we learned today to make a prediction about what we think the graph is going to look like. So if we go to the next page, and some of you have worked ahead, so you already know what it's going to look like. So if you already know, just chill out and let us think about it. But it says first, let's guess what we think is going to happen based on the equation. So the first thing I notice in the equation is there is a 4 in front of the x squared. What do we think that 4 is going to do to this graph? Make it skinnier. 4 is bigger than 1, so it's going to be more narrow. Okay, and I tried to color code that, so that 4, because the 4 is bigger than 1, it's going to make that graph steeper or more narrow. Next we have a minus 3. What do you think this minus 3 is going to do? It's going to move the whole graph down 3. So shift down, oops, forgot a letter, down 3 units. All right, let's plug it into our graph and see what happens. So this time it is 4x squared minus 3 Does this graph look more narrow and shifted down 4? Yes, it does. Now, so let's add that in our description. It opens up because this is a positive 4. All right, take a moment on your own, go into the table, record some points. Keep in mind that some of these points might be off the graph, so you'll have to pick the points that we can actually put on our graph. All right, the points that will fit on my graph are -1, 1, 0, -3, and 1, 1. Now, I had something happen in my third hour that I wanted to make note for you. Remember that your origin, 0, 0, is right in the middle. So that point isn't on the graph. I just want you to remember that that center point, that's where you're counting from for all of your points. So -1, 1 is left 1, up 1 from that center point. I had someone try to do -1, 1 from this vertex point, and that just doesn't work right. So our parabola should look like... Ooh, that left side is not very good. Something like that. What do you think is going to happen in this one? Let's look at all of the pieces that we see. The first thing I see is a negative. What is that negative telling me? The negative tells us if the graph opens up or down. Which direction is this graph going to open? Opens down. It's going to be an upside down parabola. Next, I see the 1/4. Is 1/4 larger than 1 or less than 1? Less than 1, so that means this graph is going to be more wide. Now remember, the narrow and wide seems kind of backwards because a number bigger than 1 is narrower, a number less than 1 is wider. Think of it in terms of slope. 1/4 is not very steep, so it's going to be a wider parabola. A slope of like 5 would be super steep, that would make a narrow parabola. The next thing that I see is +5. What is that +5 going to do for our graph? Up 5 units. All right, let's put this in the graph. I want you on your own to put that equation into your calculator, get some points, make your parabola. When we look at the graph, I'm already noticing how wide this graph is, so we definitely made the correct assumption that it'd be wider. It also opens down, and it looks like it has moved up 5 units. When you go to the table, because a fraction was involved, there might be some decimal points. We don't really want to graph decimal points, so I'm going to write down -2, 4, 0, 5, and 2, 4. Okay. Now, when I plot those points, let's see what happens. Because look, the 0, 5 is bigger than 4, so that middle point is up from the other 2 points. Now, this doesn't look like a whole lot to me. I kind of wish that I had another point. You don't have to write points in order in this table. So if I go up here and say, let's see, -4, 1, that's a point I could put on there. And if I go down on the table, +4, 1, there's 2 more points that I could put on my graph. And when I find those 2 points, that gives me a little bit better picture of what this parabola is going to look like. Use your graph to help you to draw in this parabola, making it look nice and smooth, just like it does on the graphing calculator. Okay, compare this to the graph of the parent function. We basically already did that when we made our assumptions. Ultimately, we are going to look at every single aspect of these equations so that I could give you an equation without a graph, and without a graphing calculator, you could tell me, oh, this graph is going to open down, it's going to be wider, and it's going to move up 5 units. You'll be able to tell me all of that just from looking at the equation. So that's what I want you to practice today as you work on your assignment. Your assignment is a 4-problem worksheet. You can use the graphing calculators to help you, but I want you to predict what you think is going to happen on every problem before you plug it into the graphing calculator.